Okay, so in general, hopefully we remember that the formula for any exponential function looks like this. So A is the initial amount, B is the growth decay factor. So when we're dealing with a percentage of growth, what did we say yesterday? How do we find B? If growing by a percent, that's going to be exponential growth. If it's growing by a percent. And what's B going to equal? It's going to be 100% plus R percent, or you can think of it as 1 plus R as long as R is written as a decimal. And just a refresher from elementary math, let's say I had 2%. The reason why we write it as 0.02 is per is the division symbol, cent is the prefix for hundredths. So 2% means 2 out of 100, and 2 divided by 100 is 0.02. So that's where that comes from, okay? 2%. So 25% is 25 out of 100, which is 0.25. Is that making sense? So if you were unsure, if I give you the percent, how could you convert it to a decimal? Move it to the left twice, or divide by 100 if you are ever unsure, okay? But make sure that if it's growth, we're going to do 1 plus R for B. Alright, so if it's exponential decay, that means it's either decreasing or declining, or some other words. So it's decreasing by a percent. How are we going to figure out B in this case? One minus R, or 100% minus R percent, okay? As long, again, as R is written as a decimal. So that was kind of our recap of all those tables we did yesterday. Okay. So let's take a look at 2 example sums. Number 1. Since 1995, the daily cost of patient care in community hospitals in the United States has increased about 4% per year. In 1995, such hospital costs were average of $968 per day. Write an equation to model the cost of hospital care since 1995. So we have to find the initial amount, and we have to figure out what B is. Okay, so somebody help me out. What's the initial amount in this problem? 968. Let's put a little thing here. So you understand how I'm figuring out B. Remember, B is either going to be 1 plus R or 1 minus R. What is it going to be in this case? Abby? So we're going to do add. Good. So let's change 4% to a decimal. 4 divided by 100 is 0.04, right? 1 plus 0.04 is just 1.04. So I put that up here, times 1.04 to the x power. This is an equation that models hospital care. One little note. X is the year since, when did this start? 1995. Okay. So here's our equation. All right, use your equation to estimate the approximate cost per day in 2012. So what we have to figure out is how many years since 1995 is 2012. So let's just subtract. What's 2012 minus 1995? 17. Yeah. Okay. So let's type in 968 times 1.04 to the 17th power. I gotta find my calculator. Oh no. Oh, it's right here in front of my face. Alright. And since they gave it to us in the nearest dollar, let's just leave it to the nearest dollar. This looks like 1,886 or 85, depending if you round or truncate, dollars. So it's quite a significant increase, right, in the cost per day since 1995. All right, next, so here, that was an example of growth. If you want next to one, you can put growth on the side so you remember. Let's do an example of decay. Since 1980, the number of gallons of whole milk. Who's ever had whole milk? See this case in point. When I was young, and we've established that was a very long time ago, they didn't even have like skim milk. Okay, whole milk, it was like whole milk or 2% milk. Whole milk is actually 4% milk fat, and if you've ever drinking it, it feels like it's really thick, and sometimes it's kind of probably gross if you drink it compared to skim milk. But what they found basically is since it was so fatty and you were drinking it, it would add lots of calories and things like that. Okay, so since 1980, the number of gallons of whole milk each person drinks each year has decreased by 4.1%. So that's not surprising, because when they started thinking, okay, we can have milk that still gives us calcium but is lower in fat. Okay, Bobby? No, there's no judging here. I think it's all about what you're used to. Like if you're used to drinking skim milk and somebody put whole milk in front of you, you would definitely be able to tell the difference. Yeah. What they have found is that now that it's been years, is that skim milk, when they take out the fat, that does strip some of the nutrients. So I actually went back to buying 2%, and we just don't drink a ton of milk, but when we do, we drink 2%. So whatever, it's just personal preference. But anyways, so you don't see as much whole milk on the shelves anymore. No. And so what we're going to do is we're going to figure out what the equation for the decrease in the gallons consumed of whole milk is. So in 1980, in the United States, how much whole milk did the average person drink in a year? 16.5 gallons. Now that's over the course of a whole year. All right, now let's figure out B. Is this going to be a 1 plus or a 1 minus? 1 minus. Would you change 4.1% to a decimal? I know there's a decimal in there, but it's not a decimal yet. Minus 0.041. What is 1 minus 0.041? 0.959, right? So that's my B. So I'm going to put that up here. To the x power. So here is my equation that models the number of gallons of whole milk drunk by each person. And again, x is years since 1980. Okay, B. Use your equation to find the approximate consumption per person of whole milk in 2012. What would I do to answer this question?
Because if you do 1980, yeah.
Okay. 20.
No, just kidding.
32.
Yeah.
Good. All right. So let's see how many or how much the average person drinks in 2012. 3 gallons. All right. Good.